This video is about binomial expansion. We have a binomial theorem, a plus b to the nth power. We can write down this way. R plus 1th term, that is this one. Remember, this is a R plus 1th term. So we can write down sigma notation like this is the one. Remember, this R gets started from 0. This symbol is called a binomial coefficient. Basically, that's a combination. And read as n taken R or n choose R. It can be written as n choose R. N taken R equals factorial n over R factorial times n minus R factorial. N factorial equals 1 times 2 times 3. Keep timing until times n. For the binomial coefficient, we can also use a Pascal triangle. Here's an example. You see the x plus y to the 0 power is 1. X plus y to the first power, that's 1, 1. X plus 2 squared, that's 1, 2, 1. X plus 3 to the third power equals 1, 3, 3, 1. Keep going. So sometimes when n is a smaller number, we can use a Pascal triangle to expand the binomial. Let's do some example. Expand each binomial. For number 2, 3 minus y to the third power. We can use a binomial theorem to write down this form first. Consider this is a, this is b. Therefore, we can write down 3 choose 0 plus 3 choose 1 plus 3 choose 2 plus 3 choose 3. Remember, n choose 0 and n choose n equal to 1. Then we go to a. For a is to the third power. A squared. A first power. A is a 0 power. Then check b. You get negative y to the 0 power. Negative y to the first power. Negative y to the square. Negative y to the third power. Then we work this out. You got 27 here. This one, that's 3 times 9 times negative y. Therefore, minus 27y. For here, it's 3 times 3 times y squared. Therefore, plus 9y squared. Then, minus y to the third power. This will be the expansion for number 2. We can also use a Pascal triangle since this is a third power. That means this is 3. This will be the binomial coefficient. Therefore, I write down 1. Here's a 3 plus 3. Here's a plus 1. We still count this is a, this is a b. Therefore, we got 3 third power, 3 squared, 3 first power, then 3 0 power. Then go to negative y to the 0 power, negative y to the first power, negative y to square, then negative y to the third power. So we work this out. You got 27 plus, here's a 27 times negative y. That's a negative 27. So negative 27y plus 9y squared. Then we get negative y to the third power. Now let's go to number 3. We count, this is A, this is B, and n equals 5. So first step, you will write down 5 choose 0 plus 5 choose 1 plus 5 choose 2 plus 5 choose 3 plus 5 choose 4 plus 5 choose 5. Then your second step, go to this A. We do 3h to the 5th power, 3h to the 4th power, 3h to the 3rd power, 3h to the square, then 3h to the 1st power, then 3h to the 0 power. Then you go to this B. We do the 2g to the 0 power, 2g to the 1st power, 2g to the square, and 2g to the 3rd power, 2g to the 4th power, and then you have 2g to the 5th power. Then you work each term out. This will be your answer. Please check the variable. The addition of exponents will be 5. Like here's 5. 4 plus 1 is 5. 3 plus 2 is 5. 2 plus 3 is 5. 4 plus 1 is 5. Then 5. For number 10 and 11, represent the expansion of each expression using sigma notation, which means this one. Remember the r always gets started from 0. So we got the n equals 22. And this is A, here's B. We can write down sigma notation. The r gets started from 0 to 22. Then we have 22 choose r. 3f to the 22 minus r's power times negative 3 over 4 g to the r's power. You don't have to simplify, just leave as it is. For number 11, we know n equals 36. Therefore, r gets started from 0 to 36. 36 choose r. 1/2 s, we do 36 minus r's power times negative 5t to the r's power. For number 14, find the coefficient of indicated term in each expansion. Third term, that means r equals 2, because this one is r plus 1's term. Therefore, when you're working on this r, you always using your term minus 1, you get 2. Therefore, you will get 8 choose 2. 4x, you do 8 minus 2 is 6 power times 2y to the 2nd power. Then we put into calculator, you will get 458,752x to the 6th power y squared. That's the third term. For number 16, sixth term, that means r equals 6 minus 1 equals 5. Therefore, sixth term equals 12, choose 5, 2c, do the 12 minus 5's power, times negative d, do the 5th power. The answer will be negative 101,376 c 7th d to the 5th power. So the coefficient will be this one. Find the coefficient of the indicated term in each expansion. First of all, get the general form. General form, you will get 14, choose r, then 2a, do the 14 minus r's power, then 3b, you do r's power. We are looking for a to the 6th power and b to the 8th power. Therefore, we only look for the variable. We have a to the 14 minus r's power times b to the r's power. Supposed to be equals a to the 6th power and b to the 8th power. Therefore, we got the r equals 8. Now we plug r equals 8 back to this general form. You will get 14, choose 8. 2a, do the 14 minus 8, that's a 6th power. And then 3b, we do the 8th power. Then we put into calculator. Answer will be a huge number like this. Now let's go to number 20. For number 20, still we need the general form for that. T equals n equals 15, so 15 take an r. Then 4x, we do 15 minus r's power. Then negative 6y, we do r's power. Check the variable only. We have x is 15 minus r, and y, do the r's power, supposed to be x to the 8th power, and y, do the 7th power. We can solve for r equals 7. Then we plug back in here. You will get 15, choose 7. 4, we do 15 minus 7, that is 8. Then negative 6, do the 7th power. Then we put into calculator, you will get 1.18 times 10 to the 14th power, 24. We have 2x squared minus 1 over x to the 12th power. We need x to the 12th term. First of all, we write down the general form for this binomial expansion. That is 12. Choose r. Then 2x squared, do the 12 minus r's power. Then we have negative 1 over x. We do r's power. Now we organize the variable x. We got from here, that is x to the 2nd power, then do 12 minus r's power. Then times this part, we got 1 over x, that means x to the negative first power, then to the r's power. So we get, this is a power multiply. X is 24 minus 2r times x to the negative r's power. Then we, multiplication of power, we add exponents. So 24, combine like terms, negative 2r plus 1r, that's negative 3r. We set up this one equals 12, because here's the 1, 12. We need x to the 12th power. Then we solve, you will get the r equals 4. After we get the r equals 4, we can plug in this general form. You will get 12 taken 4, 2x squared to the 8th power times negative 1 over x, you do the 4th power. Then you put into a calculator, you will get, this will be the coefficient. Now let's go to 26. We still need the general term for this binomial expansion. So we got 9 choose r. Then x to the 9 minus r power times negative 3 x squared, we do r's power. Then we figure out variable x. This one, we can get the x to the 9 minus r power times 1 over x squared. I can do x to the negative 2nd power to the r's power. So we get x to the 9 minus r's power times x is negative 2 r's power. So we get x to the 9 minus r minus 2r will be minus 3 r's power. Constant term, that means the exponents equal to 0. So r equals 3. Then we plug back in here. You will get 9 taken 3. X is 6 power times negative 3 x squared, we do 3rd power. So we get, answer will be negative 2,268. Let's do 27. Consider the expansion of x plus b to the 7th power. Write down the general term. For the general term, n equals 7. Therefore, 7 taken r, x, you do 7 minus r's power times b to the r's power. Figure out the b, given that the coefficient x to the 4th power is negative 280. For x to the 4th power, therefore, 7 minus r equals 4. R equals 3. Therefore, we go back, plug in. You will get 7 choose 3. X to the 4th power times b to the 3rd power. We know coefficient is negative 280. Coefficient for x to the 4th power, that is 7 choose 3. b to the 3rd power equals negative 280. Therefore, b to the 3rd power equals negative 280 over 7 choose 3 equals negative 280 over 35. That's b to the 3rd power. then equals negative 8. b to the third power equals negative 8. b equals negative 2. Let's go to 28. Find the coefficient of x to the fifth power in the expansion, this one. First of all, we still need a general term for this one part. Therefore, you will get 8 choose r. Then x squared, you do the a minus r's power. 1, you do r's power. This answer is 1. So basically we got the 8 choose r. X is a 16 minus 2r. Then we multiply by x plus 2. Using this general form, 8r, and then x is a 16 minus 2r. We do distributive property. You will get 8 taken r, x 16 minus r plus 1, then plus 2 times 8 taken r, x is a 16 minus 2r. Since I'm looking for x to the fifth power, therefore, these exponents you have to set up equals 5. For these exponents, we have to set up equals 5. Then we solve 16 minus 2r plus 1 equals to 5. Then move 2r to the right side. You got the 17 minus 5, 12 equals 2r. So r equals 6. For this part, we got 16 minus 2r equals 5. Then 2r equals 16 minus 5. R equals 5.5. Since r must be natural number, therefore, this one is gone. In other words, only we have this, and the coefficient will be 8 taken 6. We put into calculator will be 28. Now for 29, consider expression. Find the term in which x and y are raised to the same power. First of all, we will write down the general term for this binomial expansion. You will get 6 taken r. X squared y do the 6 minus r power. And 2y squared, you do r's power. Then we need to organize for x and y. So we get x 12 minus 2r times y to the 6 minus r's power. Then times y to the 2r's power. We only care about x and y, the exponents. So we get x is 12 minus 2r. For y, we got adding, you got the 6 plus r. This said x, y are raised to the same power. In other words, 12 minus 2r equals 6 plus r. Linear function cross, you will get 6 equals 3r. So r equals 2. Now we plug r equals 2 to this general form. You will get 6 taken 2. Then x squared y do the fourth power. Then 2y squared do the second power. We organize. You will get the 60. X eighth power y to the eighth power. This is the term we are looking for.